Good day to you, my dear friends. It's time to solve some LeetCode problems. And already it's a very hard day because I had such a difficult run today. Because I run, and on Fridays I have the longest runs, so I'm wasted already. But it's not an excuse, we still must solve something today. And yesterday we managed to solve medium problem, but today is not the day. Today we'll solve some easy ones, but before that let's check some problems from yesterday. For example, this is a funny one. Number of even and odd bits. I solved it yesterday in a kinda brute force way. Oh no, not like this. Hey, where is my submission? Like this. What? Yeah, like this. So this was my solution from yesterday, and yeah, it's kinda brute force and it has strange if conditions, but it's not actually a bad solution because we iterate only once. It's not bad, but it's not clever. That's the problem. And that is a clever solution. Just look at this. Well, of course we want to call the resulting array answer because that's what they ask in the description. See, like this. But what the hell is going on here? Well, a funny thing. First of all, we use this AND operator. How can we call it? Ampersand operator. What does it do? Well, it compare bits. So it compare numbers in this case in the binary form, in the binary representation. Smart Coder 5. Hello, nice to meet you. Oof. So if we have, for example, something like this, let's see what we're gonna get. It doesn't work like this. Yes, we should just use numbers, integers here, not strings. Right? Right. So output, you can see. Why it's 1 and 0? Well, because when we use this AND, this ampersand, say we have something like this, and I don't know, oh, no, something like this. When we have the same number, the same digit at the same place, at the same position, we take it. If they differ, we take 0. So we can say if it's 1, we take 1. If it's not 1, If it's like 2 zeros or 1 and 0, then we take 0, you know. So here it's gonna be 1 1 and 1. Oh, why do I call it 1? 0 0 0 and 1, something like this. And what do we do here when we do n and 3 4 1? Let's check. Three, 4, 1. To string and in its binary form. So this is a result. Code golf? I know nothing about code golf. I guess I am. Why not? No, I'm up for pretty much anything. And let's look at our n. What is a constraint? You see, it's less or equal to 1,000. Now, let's check 1,000. It's binary form. Look at this. Let's compare. As you can see, our 341 is shorter. Get beaten by Ruby solutions? It's impossible. Ruby is slow. So, as you can see, 341 in a binary form is shorter. And what if we have a 1 in this index, in this position? Then we are going to lose it. But do not worry. Do you remember our condition? That we want in our answer, as the first element of this array, we want to count only even indexes. So it's this one. You know, let's imagine that we have this number. So what are we going to take? And remember that we count indexes starting from the right. So the very leftmost element. Ruby source code can be very short. Well, it can be, I guess. So we do not care what do we have here, because this position, this index, is not even. It's an odd index. That's why we can afford not to even care about this number. What do we have here? We only care about all these. And so we compare our n and 3 for 1 in binary form, and as a result we get, what do we get? Let's see. We get all the ones in even positions. And then we count them. I mean, it's not very beautiful in the sense that we have to count twice, and we have to count once, of course, not just everything. But it's not a big problem because, well, it's a beautiful solution. And for the second number, we use 682. Why is that? Because it's 2 times bigger than 341. And we discussed earlier in previous problem like a week ago, do remember that when we multiply number by 2 in a binary form, we left shift everything. So if we have 341, wait, not to S, not to N, to S. Oh, it's very hot, I can't think. Yes, we have this output. And let's compare it to six, 8, 2. And we are going to notice something. You see, this number is exactly the same as this number, but left shifted. We added 1 0 to the right. Because now we count odd indexes. This one, this one, this one, this one. So the first one matters here. And again, in the end we want to do digits and to count ones. Yes. I mean, it may be not a very good solution in terms of space, because we create this extra arrays. You see, everything good. But it's just beautiful, you know, sometimes beauty is the most important thing. Well, compare it to my monstrosity. Where was it? Where was it? This one. Look at this. And it's not very readable too, you know. What the hell is going on here? But we do not have all this, you know, unnecessary arrays. We even iterate here, not through array, but we use while loop. So just know about both solutions. Probably I should upload mine. It's not beautiful, but you know, Ruby section is slowly dying. Just 2 solutions and they are the same. From the same guy. Let's at least upvote him. Beauty is in the eye of the beholder. Well, yeah. But generally speaking, no one loves this huge, chunks of code with if blocks. I mean, it's a sign of a bad programmer, not a bad programmer, but a newbie. And that's what I am, in a sense. So that's why my code consists of so many ifs. And now let's continue with another problem from yesterday. It's a medium problem that we solved. First try, by the way. Again, it's not very beautiful for the same reason. It has so many ifs. It's probably unreadable by other people. But my, assumption to use hash was the right one, because all the other solutions, they use hash too. The only difference is how they treat this hash, because well, let's discuss the problem itself, because you probably do not understand what is the problem. We have these group sizes. You know, what does this mean, this first three? It means that a first person is in a group that consists of three members, and this one and this one. So these guys, you know, they are in one group. So person number one, number two, number three, they are in one group of three people. And then we can say that it's not 1, 2, 3, of course, it's 0, 1, and 2. The same is true for, you know, this one and the last guy. And this guy, he, you know, he's a lone wolf. Oh no, I typed something accidentally. That's what we want to do, and I did it using the hash. And all the other guys did the same thing, but some of them no, that one is too hard. Like this one, you see, he created the hash, populated it, and after that he iterated through each key and value. And he did something like this. Other guy did, let me show you. Say we have store. Push, and here we're gonna have this hash key, and then we're gonna pop. How many elements we're gonna pop? We're gonna pop like the key itself. But I do this on my first go, you know, and I think it's better, but it's slightly less readable. The only like problem with my solution is that I check, you know, every time I check if I already reached group size. So I waste some resources here, but still it's a nice solution. You know, there is a one-liner there somewhere, but it's very awkward, you know, for my taste. Look at this. Oof. It's a nice exercise, but, you know, it's crazy. Let's try it. Okay, it works. Well, I like my solution. I think it's not bad at all comparing to other people. Now let's look at some problem from the past that I solved some time ago, but we didn't discuss it yet. And I think it's gonna be a JavaScript problem. We already discussed all these problems. No. I think function composition is the next one. Well, yes, we have an array of functions, and we want to call these functions. Each of the function we want to call on the result of a previous function. And notice that we have these functions, but we want to call it starting from the right, and we have a method in JavaScript just for that. As you remember, we have a reduce method in JavaScript, but also we have reduce right, and it does pretty much the same thing, but it starts from the right, not from the left. Let's just do it. So we want to return a new function. Okay, so return functions reduce right. Oof. See, I'm sweating. It's not because this is a very hard problem, it's because of the weather. What is it today? Let's check. 36 degrees Celsius already. It's gonna be even hotter. It was like 39 yesterday. And I had a long run today. Imagine, in these conditions. I don't know how I am still alive. It's a miracle. But we are reducing here. Let's not get distracted. And of course we have a accumulator, and we have an element. Let's call it func, because I am in a funky mood today. And what do we want to do? Well, we want to call func on a accumulator, I think. And we also have to specify a starting condition, and for us that's x. And maybe that's it. Maybe it's not. Let's check. Yeah, everything is green, so it's not a very hard problem. Well, no big surprise here, because we are in an easy section. And some people, they turn this into an arrow function, something like this. I do not need this anymore. Let's check. But I do not like this approach, because we ruined an original condition. Let's cancel. You see how it looks? It means that we have to we shouldn't ruin this structure. It's given to us as a condition, as a rule in our problem. So I consider using arrow function here as a cheat. You can't do a one-liner here. And now, as usually, let's solve something new. Probably it's not gonna be a medium problem, because I'm wasted today. Duplicate emails. Well, let's see what's it all about. It's an SQL problem. Oh, God save us all. So we have a table person. We have ID, we have a mail. Write an SQL query to report all the duplicate emails. Note that it's guaranteed that the email field is not null. So this is an input. Select email. Nah. Well, let's start from something easy and then we are gonna of course. Okay. Let's group by email having, don't remember how we use it, count probably it's wrong. Of course it's wrong, but let's see the result. Oh, what do we have this one? Now it's not that easy. Wait, what happens when we group by email? We have this two, right? Right. And we can't group by ID, right? It's impossible here. Oh no, we can group by ID. But why would we do that? Okay. Oh, it's awful. How do we check for duplicates? Hmm. Hmm. Okay, but I did all that. First, use group by close to group all rows by the target column, which is the column that you want to check duplicate. I did that. I did that. Uh-huh. Yeah, still gonna need this later. Let's use it as a reference. Count mail from person, of course, and group by. Email and having. But I did all that. So what's the problem here? I see. Ah. Of course we do not need this anymore. That's easy, and my mistake was that I did something like this, right? Oh, bloody moron. Ah. Yeah, that was the problem. No, it's good that I have to repeat these count related problems again and again, because I just can't remember syntaxes for the life of me. So select email as email from person, group by email, having count email, more than one. Easy. Great. Now I can have my rest for today. And I'll see you tomorrow, I guess. It's gonna be another day and another LeetCode problem. I think I will attempt a medium problem again tomorrow. So we're gonna have a lot of fun tomorrow. I'm so tired. Goodbye, goodbye. Where is this button? Oh, here it is.